we are looking at a displacement reaction wherein the lead is displacing copper. So first thing first, let's identify who are involved. So we have lead, we have, this is your copper to chloride. Then, okay, we have another name for this actually. This is your cupric chloride. Then we have your lead, chloride, and then you have your copper. Is it balanced? Generally, they look to be balanced. Let's see. You have lead, then you have cupric chloride. Just a second, let me write. Then you have lead, chloride, and copper. So we have lead, copper, and chlorine. So we have 1, none, 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 1, 1, 1, 2, sorry. Then we have 1, none, 2, and none, 1, and none. So this is balanced. Okay, so all I did was write the reactant on the topmost row, and the column in the first, and the column has the first column has the all the atoms involved, and then we map the values and we have the answer that it's balanced. In this case, we don't have to do much. So what exactly is happening? The solid piece is dipped in your aqueous solution. This leads to, right, this being aqueous and this being your solid. So the lead displaces copper. Okay, so there's no external agent needed for this to happen. That is spontaneous at room temperature basically. Okay, the most difficult part for you guys over here. How do you check that the reaction has happened? Color change. First we start with the solution. So we know that this has to be blue, if not green color. Right, this is again due to Cu2 plus. This will fade. This will fade out as a lead chloride, which forms a colorless solution. Okay, so this is colorless, right? Again, when you see it practically, then it will be easy to remember basically. Then the formation of the solid. So again here too the same thing, reddish brown. So it's that simple. So this will be deposited on the surface of the lead metal. Reddish brown formation of the solid actually. Let me write that. Formation of solid. That is we're looking at reddish brown solid. So we have metallic copper will deposit on the surface of the lead metal. So we have the copper depositing on lead metal. So there is change in appearance. So a dull gray lead metal will be consumed as the reaction happens, and the reddish brown copper will deposit in its place. Basically, that's what is happening. Then of course, finally you have heat being released. And that's an example of your exothermic reaction. So the reason is quite simple. You have, in this case, lead to be higher in reactivity series than copper. It's as simple as that. And why is there a release of heat? Quite simple. Your initial, PbCuCl2, PbCuCl2, it's of higher energy level compared to the resulting, that is PbCl2 and Cu, which is lower. And this is nothing but difference in energy. That is, the energy is reducing. So this has to go somewhere. Energy cannot be created, not destroyed. And this will come out as heat.